When we're finding the volume of a cone, we need to know two things. We need to know the radius of the base, and the base is a circle, and we need to know the height of the cone. So we need to know radius, and make sure, very often they might give you the diameter, so make sure you cut that value in half if they do. And just a note, no matter where that circle is, it is always the base, no matter what the orientation is, okay? All right, let's give this a couple of numbers here. We'll say the radius is 3 units and the height is 6 units. Okay? And let's look at these formulas here. These are equivalent. The difference is in this one, they use a capital B to denote the area of the base. And the area of the base is a circle, and the circle is pi r squared. Okay? And for me, I prefer this because I'm going to have to do it anyway, so might as well start with all the information. So let's go ahead. We have everything we need to solve this, so let's go ahead and start doing that. I'm just going to bring it down 1/3 pi, and my radius is 3, so that's going to be 3 squared, and then my height is 6. Okay, again, I'm going to bring it down to 1/3 pi. 3 squared is 9. Times 6, I know that 9 times 6 is 54. Pi 1/3. Okay, now I'm going to leave the pi here, and then I'm going to do 54 over 1 times 1/3. Okay, and you could write this like pi and then 54/3. It doesn't matter, they're both the same. Okay, but either way, we need to divide 54 by 3, right? So 3 goes into 54. So 54 divided by 3, 3 goes into 5 one time. We're left with 24. 3 goes into 24 8 times. Okay, so now I have my answer, 18 pi. Okay, now if they ask you to leave the answer in terms of pi, this is what they mean. All right, it just means the pi is in the answer. The symbol pi is in the answer. Okay, they might have you say, work out, well, what if pi is 3.14? You might have to do it on the calculator. Sometimes though, when you're working on like a standardized test, sometimes you don't use a calculator, so it's good to know how to do this. 4 times 8 is 32. 8, 9, 10, 11. 3 times 8 is 24, and 1 is 25. And then we've got 1 times 4, 1 times 1, and 1 times 3. So we have 2, 5, 6, and 5. And now we have to deal with the decimal. All right, so now we have 56.52. And I forgot to write the units, but it's going to be units cubed. Units cubed because I didn't specify what the units were on the cone. All right. Okay. One other thing I wanted to point out, if you need to memorize this formula, I think this is really helpful. If I have a cylinder that's exactly the same radius on the base, so in this case it would be 3. I'll do different colors, this would be 3, and the same height for the object, in this case 6 units, then I know that I could fill this cone up 3 times and it will fill this cylinder up. Okay, so one cone will fill it up 1/3 of the way. 2 cones will fill it up twice, and then 3 will fill the whole thing up. So, and that is evident in this equation. Okay, so the equation for the volume of a cylinder, I realize that I use C for cone and C for cylinder here, so this is the volume of a cylinder. I'm going to draw a little cylinder. Okay, so this is going to be pi r squared h. All right, so do you see the difference between this and this? It's this 1/3 right here. And that's what tells us 3 of these will go into here. Okay, so I hope that helps. It shows me that there's a relationship between the cone and the cylinder, which I think is pretty cool. Anyway, I hope this helps, and I will see you in the next one.